Okay, thank you. Good evening, because it's evening in my country, Bosnia and Herzegovina. It's 9 o'clock, and I believe it's 3 o'clock in your country, in your Eastern time zone. So thank you, everybody. This session will be recorded, so if someone doesn't make it right now, he or she can maybe watch and learn something new later when they have a time. So yes, the topic is data breaches, let's say like that, prevention and mitigation. Really interesting and really hot topic, especially in these days, COVID-19 outbreak, where we have a lot of situations, uncontrolled situations that we didn't expect to be happening so quickly and so eventually and so frequently. And in this mixing of different security vectors, data breaches are happening almost every day. They appear every day and before COVID, but now in COVID-19 outbreak, data breaches are more frequent. Yes, hello. Do you hear me? Do you hear me? Do you hear my session? Do you hear me? Okay, I will just continue. Okay, thank you for supporting this event, UNICEF, because this is a noble cause, and I will try to give my best as I can in this situation to support this cause, and I hope my session you will find it useful in your daily work. Also, thank you for our sponsors, because without sponsors, this event, offline or online, virtual or not virtual, are simply is not possible. And also, thank you to all the volunteers and a lot of men's and women's behind the scene, because their hard work is simply doesn't show in the first place, but they are behind and are making this all possible. Also, I will kindly ask you for your feedback after the session. Also, feedback based on my session. What do you think about it? Do you find it useful or anything else? Speaker feedback, and also please give some event feedback later after this event or this session. Okay, summary. What we will speak about is about data breaches and cybersecurity. This presentation is simply divided in three sections. Introduction part, where I will try to from high level overview explain what is going on in the space of data breaches. Then in the middle part of the presentation, I'll speak about what is missing in all process that actually making possible all this data breach story. And on the end, especially it's a central part of the presentation, I call it handle data with care, where I will try to explain how to prevent and how to mitigate data breach scenarios using SQL Server. Okay, in this introduction part, I have 5 slides. It's a simple high level overview in the space, in the look, in the perspective of the modern environment and the data breaches that are happening everywhere. But before we start, I believe this presentation will be interesting to developers and DBAs and data developers. This top 10+1 best security practices is simply from their perspective. Each person that actually write the code, I don't know, C#, Python, Visual Basic, C++, doesn't matter, should try to implement this at least 10 plus 1 is a bonus. Plus 1 is actually learn continuously. But in this space, if you doesn't follow this practice, you can fall in a trap that your code, your application, your environment become easy target to hackers, to anybody with malicious intention. Actually, the one part is data related mostly, and this is handled data with care. Okay, how data breach occur? Simple, there's many scenarios, but in this simple slide, we can start like this. Okay, but important part is that you never underestimate the person, the group, or population that are trying to be malicious to you, to you personally, to you as a business, to you as a company, to you as a group, doesn't matter. Never do underestimate, because we don't know the reasons, we don't know the resources, we don't know the financial cause that other side is ready to sacrifice to make you damage. Okay, the research part is when the individual or group simple try to look the weakness and weakness inside your all environment, to spot the weak point, sweet point, and try to exploit. Okay, when they find something that they can use, we are jumping in phase 2, stage attack. In stage attack, the person, the group, are trying to use different vectors of approaching: social engineering, infrastructure weakness, web server weakness, phishing emails. There's a dozen examples how this part can be used. For example, let person A, malicious user, find the open port inside your server. That port is not blocked on your firewall, and it will accept the network command, and it will accept the command from other side: Telnet port, I don't know, SQL Server port, FTP port, remote access. There's a different kind of ports where other party can try to exploit. Also, another scenario, the user can send a phishing email with a payload inside that email, inside the link, and send to all company emails. I can bet that at least one of the emails will get the click, and the click is enough, because we are all working, let's say, with admin permissions on our own PCs, on our business PCs, and that's enough. That payload is simply delivered to target machine, and payload will try to exfiltrate the other resources inside your environment. Another step is step 3, access to database, access to your files, access to your emails, name it, you name it. And the final step, the user, the malicious user can't simple copy that file as a Control X, Control V to their own PC. They need to try to find different ways to, for example, start HTTP on another port, open the unknown website, try to start FTP telnet session to simply transfer the files, data files, emails, everything that's interesting to them to their own location. And that's how data breaches occur. It's as simple as that. But there's another scenarios like this. Okay, if you are looking from the DB perspective, database, I believe each one of you who actually write the code and dealing with data on daily basis will recognize at least one potential malicious point. For example, backup files. How many of us is copy backup files to USB drives, SD cards, mixing the staging environments, testing environments, production, and simply that backup files are going from A to B, and that's totally out of control. Also, same as data log files. Attach and detach these files to simply recreate environment to where you can do your daily job is also can be used as malicious. Also, oversized DB permissions. What it means? Don't give the user or group the maximum permissions, because simple we are too lazy to click deny, allow, write. For example, we give them SA, we give them security admin, and from that point you are creating the totally new endpoint in security, with the possibility that that group or user inherent permission and pass that permission to other users, and you will create a whole bunch of new users inside your DB that you simply can't control the situation, and so on. And if you watch this pie chart on the right of the slide, data stealing analysis, you will see that in all these scenarios, 90% are hacked. So people from outside of your company, outside of your environments, are easily can hack through one of these attack vectors. 10% is other. What is other? We will see later. Okay, more details. Black data, let's say black data. If you see down below on the left, these are the trends in 4 segments: laptops, DBs, email, and tapes in a timeline. And you will see that, for example, laptops in all these scenarios, we have 47% of attempts, and of that 47%, 25 is success, and the risk is 11%. Okay, let's jump in DB. In all the pool of attempts in one timeline, the 40% is on DB, and the most scary part is that 64% of that attempt are success. And you see the total risk is 84, and you see that this red line is going sky high. What it means? It means that we are using DB. We are speaking about security. We are using encryption policies. There's a lot of security story, a lot of hidden fuzz about this, but the green line is going high sky. So what is going on? Why is that? I will try to explain that later in the presentation, and I believe you will get it on the end. Why in this situation we are speaking about security in everyday data are stolen every day. Okay, and I believe this slide it will be simply mind-blowing. You can type in your search engine world biggest data breaches hacks, and you will get the first link. It's called information are beautiful / world biggest data breaches and hacks. So what is this? This is a reported cases on the timeline grouped by companies, and also grouped by the number of database records actually breached. And you'll see there's a lot of famous names: Facebook, Marriott Hotels, Twitter, Occident, Microsoft, Equals. Down below, you see down Uber, Yahoo, and also down there in 2016, 15, 14, there's a winner, epic winner, two times with 1 billion. I will say again, 1 billion records inside. It's Yahoo. So 2 times in history, Yahoo was breached, and it was leaked 1 billion per leak number of records. And again, now when we see Yahoo, Microsoft, Facebook, Ashley Madison, Uber, government institution, Delight, and also we can simply ask the question: why is it possible that this can happen to me? Yes, it is possible. And the most dangerous part in this situation is when we say to us, it's a false sense of security. When we say to ourselves, this will not happen to me. I am not so interesting. I'm not dealing with that kind of data. Who will blackmail me? And so on and so on and so on. And in one point in time, we are hacked. You are hacked. And that's the point. If you are, if we are not prepared, it can knock down our business, our company, ourselves, really down below. Okay, so what is missing? Why this is happening? We can speak. Believe me, in next 8 hours. Why is this? And I believe each one of you will give reasonable argument in their opinion that makes sense. This is one of my opinions and my proposals, what we can do in our own environments to make this cyber security story much better than it is now. I believe on other side of this conference, to all of you who are now listening, and you listen maybe later recorded session, that you have some kind of cybersecurity department in your company, and that's cool, that's nice. But is this cybersecurity department funded on the right direction? I'll try to explain in next couple of slides. Okay, my first part is threat modeling. The ABC of all security start with the risk. So we can't just jump on web interface and say, okay, I will on this form pay attention on this input, I will take care about that. In DB, I will try to put encryption, or I will try to use SSL. All these arguments make sense, but they are not systematic. They are simply just brainstormed. And that's okay, but in security, this is not so okay. So there is a formal approach. It's called threat modeling. There's a lot of books, blogs, tutorials, how you can do threat modeling. Basically, this is about describing security aspects of our systems. What it means? It means that you will divide your security project, all your sprints, your user stories, every step in mind should be as a security. I simply miss to put one more slide in the presentation, and I apologize for that. It is about agile. I believe many of you using agile in their job, and agile is fine. They're agile from one side and DevOps on the other side. Simply makes things better, faster, and more agile, as the same name. But there is if you look tenant of documents of agile documentation, and if you search. But by Control F in your browser, in your Word, I don't know the tool you're using. If you search for word security, you will get zero result. I will spell it again: zero result. No security at all. So security is left behind in agile, and that's the major. And I respect agile, but lack of security in that methodology simply produce in last 10 years a lot of data breaches, because programmers simply does not care about security if there is no specific request. So we need to put security back in the process from the analysis and to design, to writing the code, to the deploy, and back on the square one and through iteration. So it will minimize potential cost, minimize need to write code. There's a lot of benefits about this, and the most important part, you will spot this these security potential weak spot in the early beginning phase, not later. For example, one web form, and that web form, for example, has some login data, 2 text boxes, username, password, login, cancel, and I forgot the password. So when you put this form through the threat analysis formal method, the major point of security is SQL injection, that you prevent user to not type SQL code, SQL command through the user interface. And to prevent that, you will need to take care through the different layers of the application. Application layer, business logic, user stories, database layer. There's a different layers of your system that you need to take care. The most important part in SQL injection is that you use dynamic SQL, and there is a mitigation techniques. And if you are not using input validation, you will get SQL injection attack. So based on this example, I believe you are getting the picture what is about threat modeling. Now I will leave you simply to think about this process and try to see, is there any chance to think and to implement this kind of technique inside your environments. Okay, and last part of this, what is missing in security story and why security is so bad is simply that the most organization, and that's unfortunately still look on security as non-functional requirements. So I need you when something goes wrong. I need you to implement encryption. I need you to take care about this, but not I need you to take care of security from A until Y to my company in all segments. And that's one of the problems. So you need the SISO, C position inside your company, who will take care or she will take care about security through the policies, strategy, standards, ISO, to simply to create a plan how to integrate and maintain security. Now you need implementation part, operational part, that will actually implement this let's say war plan in security. And these are security specialists. There's a different kind of names, but one of the mostly used are security specialists. So application security, system security, network security, and so on. And also you need an ethical hacker. So you need a person that will try on an ethical way to break down security inside your company. And in this part, we are jumping and we are speaking about red team and blue team. I believe that if you put on the table, let's say 10 companies, maybe, and I say maybe, 1 of 10 have the red team and blue team. What is that? Red team is one number of people, let's say 5, let's say 2, and the major goal is to break the security inside the company in all aspects: application, network, system. They will simply try to knock the company out, but in an ethical way, because these are our boys and girls. So they will explain to us, we are finding and we are fine these exploits, and we need to fix it. And also the blue team is let's say good guys that actually try to prevent red team to hack the company. So basically, it's a struggle. It's a fight. It's a good fight between inside the company, inside our own people, to defend offensive and defensive security, but in not on destructive way. And the final part is when the breach is happened, when something goes wrong, when security incident as a lower level and the breach as a higher level shows up, the team needs to jump in and simply execute the steps A, B, C, D, F, D, G, and so on. And if you don't have the incident team, response team, you are stuck with security inside the company, which they are blaming themselves. You are guilty, I am guilty, you are not guilty, who will do that? And that's a scenario that you can afford to your company, especially in that case. So you need to have the team, drill team, simply will jump to start to fix the situation. Depends on the size of the company, depends on the business, depends on the actually business plan. You will need to inside this couple of bullet points to see I need this or I don't need this. But you need the SISO, you need a plan, and you need at least one ethical hacker who actually try to break through. Okay, now we are jumping in the concrete part. Handle data with care. And this part of presentation is simply tied to SQL Server, because if I want to be more concrete, I need to start with one DB platform. If I try to be more general, to cover SQL, Postgre, MySQL, MariaDB, Oracle, I don't know, then I will say a lot, but I will say in essence nothing. So I will try to be more specific, more concrete, but because it, I need to use one platform as a role model. Okay, database server security model. I believe all of you here are at least familiar with one or not or all items on this slide. So database as a server and database as a data collection as an instance on server gives you a different spectrum of security items to tune, to configure. Everything starts with the login. So the login is the first part of authentication. Who am I? Okay, that's the one question. Who are you? I am Jasmin. But second part of the question, are you really Jasmin? And that's the most important part. Everyone can lose the credentials. You can be hacked. You can be sniffed. You can be simple target of the attack, and that your credentials are leaked out. You are not aware of it, and someone is using, I don't know, to access your resource, and you simply don't know that. And that's that part. Are you really that person? And that's that section where I would just mention 2FA, two-factor authentication. So I'm Jasmin. Yes, this is challenge. I give you a request. I giving you a number. I giving you one more factor and give me a response. And that response is mostly one-time password. And that password or that token will be never reused again. So we will enforce the freshness and will enforce this application part. On truth layer, we are speaking about authorization. Okay, what you can do inside my system? Read, write, modify, delete, and so on. And this part of authorization are going in two directions: server side permissions and database side permission. And we are going to the column level. So SQL Server can give you out of the box on the click permissions to the column level with some kind of command with SQL Server 2017 and 19. We are speaking about row level security. When you can say, okay, first 5 records you can read, next 5 you can write, and until end you can do anything. Simply you don't see them. It is not out of the box. And when I say out of the box, I mean you can simply click it. So you need to type command. So yes, in a nutshell, it's inside the engine. You can use it, but it requires more SQL skill set to implement a row level security. But you can go easily to the column level security. Okay. Also, when you install your DB engine in cloud, on premise, on hybrid solution, you name it, there is a couple of steps during and after installation. If you leave them like that, and if you don't pay attention good enough, you can create endpoints that can malicious attacker can use and reuse to do some malicious steps. I will go off topics for 10 seconds. There was a cases I saw them in my career. In last 10 years, where the attacker was inside the system for years, for months, until they are spotted, and they are mostly spotted on their way out, because when they are leaving the environment, it was really hard to clear all traces of activity. So the alarm is turned on that situation, but it's too late. So and all of these situations are generated because the persons or IT teams does not pay attention, especially in these steps during and after installation. So SQL Server example is simple, is childish, but childish. But look, I believe that where is the problem? When the team create the software, write the code, they are doing that in staging on farms, on testing environments, and so on. And in that environments, they have almost by default full access. In most cases, we are speaking about SA account, SA, so server administrator. So if you have source control, and if that code goes on stage and go on production, it can easily goes out with SA account or SA password hard coded inside your connection strings, and I see it a lot. Also, the protocols. For example, depends on the SQL Server version. When I say version, I mean standard, enterprise, developer, workgroup, web, and so on. Different set of protocols are turned off by default. And see this, shared memory, name pipes, and TCP/IP enabled. Why? Why I need all three of them? I need, for example, only TCP/IP. Disable any attack surface as possible. Turn it off, delete it. Simple. You need to be gone, because if you leave shared memory and name pipes and you never use it, you will forget on it, and someone will scan your network and try, and they will find it. These protocols, they are by default, and they are in. Believe me, they are in. And also the third part, in installation part, and it's mostly tied by database, is about user password. If you use SQL Server authentication, please enforce password policy. Please enforce password expiration policy, and please enforce that user must change password on next login when you create password for them. Yes, I know it's painful with the forwards. It's boring to change. Who will remember password with 16 characters, 12 characters, special sign, and so on? But without these steps, any sniffing attack will sniff the hashes of password, and it can be easily brought and hacked to the modern GPU cards, server farms, and so on. Also, the part that most of us are simply ignore, and we are speaking about threats of unauthorized users. What it means? The users inside our companies. So we are buying the firewalls, application firewalls, and so on, to defend ourselves outside. But what if threats goes inside? And there is a number of cases where employees, because reasons A, B, C, D, name it, simply they are trying to do some activity that is a gray zone between a regular job or malicious job, to give the data to third party, to make the benefits, to blackmail, because they hate you, because they lose the job. So there's a different set of activities where these users can try to exploit, and that's why in last year, and especially last year in this COVID-19 situation, one security model simple jumps in. It's called zero trust. Zero trust. I don't trust nobody. So I treat you inside my environment same as outside. So you need to pass to rigorous authorization section each time. Yes, I know implementation is kind of expensive. It takes time. It takes expertise. But zero trust model is something that we need today, especially now when we are working from homes. For example, this conference now is virtual. I am not in your country. I'm not in your time zone. I'm thousand miles away. And for example, that we are now in same network and my PC is compromised. It means that from my PC, attackers can compromise entire network of that company. So VPNs, 2FA, SSL, HTTPS, and all this story needs to be forced in this zero trust model. Okay, so the user role simple is not enough. So I'll just go back. So if your environment is based on just a role, I will give you read, I will give you write, or I will give you deny on some reasons. That means your security and privacy is not good enough. So this is the story. So I will give you select on I don't know DB with 50 tables. It means you can read 50 tables with your select statement. So what is the problem? The problem, I can read all of them. So I can write the statement and to see salaries, to see reviews, to see I don't know, patients' records, students' grades. It depends on the system, and I can use and reuse that information ethically or not ethically. So company is now based, and it depends on my ethical principles. So mitigation is in this scenario is also not enough, but it is something based. If you're using this is simply not good enough. But if you try to do this, you will mitigate situation, and you will make it harder to users with permissions to break through in private and more secure part of the system. So give access, deny, use store procedures, use views to map tables, deny ad hoc queries, and use encryption. I will speak encryption more later in presentation, and that's the most important part in this prevention and mitigation data breach techniques. Okay, physical data stealing. What it means? It means that we are forgetting that inside threats can easily can get data files, backup files, and all other files inside a company. If that user is authorized to copy backups, to create backups, to use company drives, cloud drives, Google, I don't know, Microsoft Office 365, and so on, it means that that user can copy all that on their own PC, remote or not remote. It means that he or she can detach and copy that files. So you have the potential breach. And I will leave you to think about this part. Part two is outside of DB. So yes, I'm DB owner, I can handle data, but outside of DB planet, you are going outside in totally different ecosystem, file system, operating level, network layer, where the other threats simply are waiting to extract your data. So you put your DB on network share, on cloud share. The file system permissions are weak. There's exploit in OS. So there's a numerous reasons where this outside threat can penetrate and exfiltrate this kind of sensitive data. Okay, mitigation. Mitigation of this part is very simple. You need to use encryption. You need to use encryption in all levels: table, column, and entire database. Again, it depends. It depends on your business process. You need to encrypt backups all the time, because the backups are the most weakest part, because they are put aside. They are putting aside backup on off-site location, on primary, secondary, tertiary location. So you have the one backup on 3 locations. Can you guarantee that all these 3 locations are top security? I can't. But if I do the steps and make the backup really hard to penetrate, even if you have the physical access, then it's a whole different story. You need to encrypt the volumes, disk drives, USB partitions with BitLocker, VeraCrypt, and different set of tools. Also, passwords. If you use classic archives, zip, 7-zip, and WinRAR, please use password, because these archives using also encryption. Limit the number of admin staff. If you have 25 admins inside your administration, you have the 25 problems. So you need to have really small number of admin staff with high level privileges. Also, the really important part is audit. If you don't have audit, if you don't who, what, and when is using, copying, modifying your data, and if breach is occurred, and if incident is occurred, you will really have a really difficult time to point the finger and say you are guilty. In almost every case, you will just say we are the breached, we are down, sorry, we will try our best, but you will never find who is doing it. But if you implement audit in all levels, and this is totally different presentation, I will simply don't have time to go deep down, but application level, web server, FTP server, DB, and even when you log, you need to make that logs are tamper-proof, because the person with most right to access to that logs can modify the logs, so can falsify them. So you need to make the tamper-proof mechanism inside your logs. And now concrete SQL Server. SQL Server has a state-of-the-art encryption mechanisms. So everything starts on the operating system level. What it means? It means when you install SQL Server, Windows Data Protection API creates server master key. Service master key is IS-256 encrypted, and it's guarded inside the master DB. Each new database will have its own database master key, and that database master key is encrypted, guarded with service master key. So it means if you need to decrypt and encrypt DB, you will need this service master key. And now inside DB, you can create the whole tree, all the leaves of the certificates, encryption keys, symmetric, asymmetric, to encrypt the concrete data inside your DB, and each of them can be fail safe of one below. So, for example, if this symmetric key is used to encrypt column, for example, credit card number inside the bank customers table, if you use this key, that key is guarded with asymmetric key, and it is guarded with the DB master key, and it's guarded by service master key. So attacker needs to have 1, 2, 3, 4 keys and know to passwords to unlock the keys. If attackers have the all 4 keys, it means it has the physical access to server, or the server is on location where attacker can simply goes and copy all these key. On the application level, I can get 1 key, But if I just pull out this key inside his comfort zone, that key is totally useless without all these three keys below above him. So this hierarchy simplified simply ensure that keys are secure enough in these situations. And these are the algorithms that SQL Server can use to encrypt DB and data. This triple key simply ignore it. It's obsolete, and from SQL Server 2016 it simply is not supported. So if you use it because this, try to change it and avoid it, because triple dash is not secure enough. So if you need to use something, use AES and use AES 256, simple as that. And if you are speaking about asymmetric algorithm, there is RSA. Again, the longest key is more secure, but longest key indeed it means it will be slower. So how much slower? It depends on your CPU power, it depends on your network, it depends on your client. So you need to test it to trade the pros and cons, to say, okay, I will use this and I will use that. And now it's a balance about security and performance. Okay, and this example of one column, first name, I will show you later in a live demo, where symmetric key is used to encrypt first name inside the database. Always, it's a really cool feature. Always encrypted eliminate the DBA from equation. What it means? It means that always one person, and it's a DBA, have access to server, have access to all key, and have access to data. So you can't simply create enough good wall to defend data from DBA. So how we can eliminate DBA from security equation? If we use always encrypted, and this encryption pulls out encryption and decryption story on client side. So, for example, DB is with data on server, and data are encrypted. So table customers is encrypted. So I will say subject name from customers where parameter at SSN is equal to that. So this is the user input here. Now this input goes to A2.NET, and A2.NET use the key to encrypt the input. So input looks now like this: 0x7ff654A6D ciphertext. So SQL Server say, give me the name from of customer where SSN is equal to this string. Because this string is inside the DB, it will results set, create result set, and send back to the client. The results came to A2.NET library, trust boundary zone. It will be decrypted and say the name is Wayne Jefferson. So encryption and decryption and key management is pulled out from server to client side. So we now need to handle security on client side, but we are eliminate this high privileged user from this story. But okay, this story has also its own side effect. So what's the side effect? There's two types of encryption that you can use in this case scenario. If you use randomized encryption, it means each time will create different encryption string of the same plain text. So 1, 2, 3 to 9. It will create one time like this, next time like that, second time like this again, and so on. So each time it creates different ciphertext. So yes, you will be secure, but you can't do any functional operation on your data. So like comparisons, summarizing, and so on, it will be useless. because each time same data looks different, and it's more secure. But if you use a different approach, so when each same string each time is encrypted on the same manner, so 1 to 9 each time will be same, so you can use like operator because each time you compare with the same string. So basically this case scenario, so this query works fine because Wayne Jefferson each time is encrypted. Because this SSN ID is always encrypted on the same way. So each time, if you're using as a primary key or foreign key, you will have same result, and that result can be used with query to create and/or operation, comparison, very close, join, distinction, rule by, and so on. So it's more flexible, but it's less secure. So attacker can sniff the network, extract the data, and through the time he or she or group can find the pattern inside the data, and maybe can decrypt that string and actually to see what we are talking about in our so-called encrypted communication. Okay, before demo, if you don't have the money, for example, because encryption is kind of still expensive sport, but it's becoming cheaper and cheaper. You can use to defend your backups, your archives with, for example, 7-zip. 7-zip is open source. It's free, and use AES-256. It's a military grade encryption to defend your archive. So there is no difference at all if you encrypt backup on SQL Server with AES-256 and create the backup and encrypt the 7-zip. You will get same level of protection. What is an issue? Issue is a key management. Who will handle the keys? Who will have the password? So in 7-zip story, you will be more exposed. In SQL Server story, you are not so exposed. So it's again balanced, but it's better than nothing. Okay, now I will show you a short demo before I finish my session about how to encrypt the data on SQL Server environment in couple of comments. Okay, I will now create quickly DB and jump in, and I will create a database master key. And this database master key is guarded by service master key. And if I query this Symmetric keys system view, I will see that this is my key that I created before a couple of seconds ago. You'll see it's AES-256, created, modified it, and some other metadata important to understand what is going on under the hood. Okay, I will now to create some test environment, some hypothetical encrypted customer table with some set of columns, and I will create certificate. So I will create the same scenario as slide before. So DB master key, certificate, and the symmetric key, and that key will be used to encrypt the concrete data. So certificate will be used to defend the key. Certificate is defended by master key. So 3 levels protection so far, and I will now finally create AES key. Just to see if someone write to me, or is everything? We are fine. Okay, nobody say anything. And now I will open the key in memory. I'll open key in memory. Okay, and I will now create a subquery to insert the customer data from Adventure DB and encrypt that data by key GUI customer SIM key created in a couple of steps before and import it in my new table. So it's simple query. Nearly 20,000 records. Okay, you'll see this is a laptop. So it simply import 20,000 rows and encrypted some of them in no time. So in no time, It's actually 1 second, one second on laptop. Now I will close the key, so it will be flushed out from memory. And if I try to see data inside the table, I see last name, credit card. You see, they're all encrypted. So this is the data which attacker can see if he or she get the DB. So if data which occur, this is a mitigation, prevention and mitigation. So prevention, that customer data is not used and exposed in deep web. Mitigation techniques is in this phase. Simply, I will try to minimize damage if damage occurs. So if I try to see data again, so again I will open the key, and I will show you side by side customer ID, last name, encrypted form and unencrypted form. You see, this is Sanchez in clear text, and Sanchez and Duffy and Belters, Erickson, and so on in encrypted way. Okay, I will now go back in my presentation. So I'm here to finish my presentation. It's 4 minutes until end. So thank you for your attention. About me, almost 20 years. I am professor at the university, and also I'm SISO in one company, and also for 11 years I am Microsoft MVP. But this is not so important. The important part is that I try to share my experience, to pass my knowledge free of charge through the conference, through the books, and through all my services. Maybe you noted on the first slide, at Jasmin Azemović is my handle on Twitter, GitHub, LinkedIn, where you can find a lot of stuff that I actually share with community on data, cybersecurity, privacy, and digital forensics. And one of that resource that actually I share is this book. So you can all of you can now go on GitHub, type my name, and you will see some of repositories down there, and you can download this book free of charge with these examples and many more of them clearly explained how to implement security on Symmetric. Yes, it's 2012, but most of the features are simply the same in now 7 years later. And yes, keep calm while we steal your data.